Hi kids, here we are with Objective 7. We are distinguishing between rational and irrational numbers. And in class, we started with this funny comic, which hopefully is funny to you. Rational number 4 is the wife of Pi. She's complaining about her husband because he's irrational, and he goes on and on and on. And that's funny because irrational numbers in decimal form go on and on and on, but they also never repeat. So remember that our repeating decimals also go on and on and on, and those are rational because we can write them as fractions. So anyway, that's a funny comic to start our lesson. Before we get going, just a quick disclaimer again, these lessons aren't perfect. They're not exactly what we do in class, but they are something. So if you are stuck at home, you can get a little refresher, maybe some homework help if you've been absent. So here we go. I'm also going to apologize. I left my camera mount at school, and so I'm a little shaky, so I'm going to try to be as, sturdy, non-shaky as possible. I don't know what word I'm going for. So these notes were a little bit different because we didn't take notes in the typical way. We went around and we collected some rational and irrational numbers that were posted around the room. So if you have not been a part of that activity, this is kind of a hybrid of our lesson, which was collecting numbers. So I'm going to show you, the solutions and talk them through. Because we have learned quite a lot about rational and irrational numbers, both in decimal and fraction form. And so this is a recap and practice of that. So we started our notes with a refresher on the difference between rational and irrational numbers in fraction form. Rational numbers in fraction form, well, they are rational numbers, sorry. If I can write them as a fraction or ratio, then they are rational. If they can't be written as a fraction, then they are not rational. So yes fraction, yes rational, no fraction, not rational. And then we talked about these numbers in decimal form. Now we learned that decimals that terminate, those can be written as a fraction, and the ones that repeat can as well. So those are rational. The ones that don't repeat, the ones that don't terminate, are the ones that are irrational. Just be careful with the subtle difference. Just because a number does not terminate does not make it irrational. If it doesn't terminate or repeat, then it is irrational. If it's a never-ending number but it repeats, remember we can write it as a fraction. So this can be a little bit confusing. There are subtle differences between the two, and that's why we are doing this practice of all of these numbers here. So these are the numbers that were posted around the classroom. And students were challenged to go around and place these numbers in the appropriate column. And so now I am showing them to you, and if you are watching, I recommend that you pause this eventually and write these numbers down for your reference. But I did want to talk them through because there are some common misconceptions that we can all learn from. The first misconception is that all of the long decimals must be the irrational numbers. But we have to be careful because some of these long decimals are actually repeating decimals that were written in the expanded way. So you'll see 521, 521, 521, ... That is a repeating decimal. We would write it in bar notation, 0.521 with a bar over it. See this bar here, right? We would have written it that way, or 0.424242, ... We would have written 0.42 with a bar over it. Another thing, this is a long decimal, and it doesn't have the ellipse at the end. It doesn't have the 3 dots at the end. So this would be 542,891 millionths, right? Yeah, I think so. So I could write this as a fraction because this does terminate, so I could put this over, 1 million, and that would be the appropriate placeholder there. So don't just assume that long decimals are all irrational. So if you look at that long decimal, look to see if there's any pattern or any indication of repetition. Another misconception was that all square roots are either rational or all square roots are the opposite. So you'll see that there are square roots or radicals on both sides. So that means there's a difference between the two. Remember that square root means what number times itself, not 2, what number times itself gives you the radicand, or the number on the inside. So 8 times 8 is 64. So the square root of 64 is 8. The square root of 1 is 1. 1 times 1 is 1. The square root of 4 is 2. The negative square root of 4 would be, therefore, negative 2. So all of these come out to be whole numbers. 8 can be a fraction then, 8 over 1, so it's rational. 1 can be a fraction, 1 over 1, so therefore it's rational. 2 can be as a fraction, be 2 over 1, which is rational. But if you plug in these numbers into a calculator, you would get some kind of crazy decimal. So for example, the square root of 2 is 1.419, I think, and it goes on and on and on and on and on. And if you look at that, there's no indication of repetition, and there's no end to that decimal. So therefore, it does not repeat or terminate in its decimal form. I can't write it as a fraction. So therefore, that square root is irrational. These 64, 1, and 4, 9, 36, all those are perfect squares, which we will learn about later. And they, again, are the ones whose square root is a whole number, which we can write as a fraction. Then we just have our normal ones that you're probably going to see quite a lot. Pi is irrational. Whole numbers are rational. 0 is rational. It's a tricky one, but we can write it 0 over 1 if we had to. Percents are rational. If it's a fraction, it's in fraction form, so that's rational. So hopefully just looking that through one more time gives you a refresher and gives you some help. All right, so we had some homework. I'm so sorry, guys. I'm reaching past the camera. I'm really missing my little camera mount thing. We're doing our best here. Okay, so here is your homework, and your job is to distinguish between rational and irrational numbers. And so you will circle the rational ones and put an X through the irrational ones. That means we're not going to have any blanks. So here I see, oh, this is already in fraction form. I know that that's going to be a rational number. And oh, I see pi. That one is our most popular irrational number. And so your job is to go through here and determine which ones are rational and irrational numbers. I just want to caution you, remember, just because it's a long decimal doesn't mean that it is irrational. Look closely at those. Also, be careful about really long numbers to see if they do repeat or not. That would be not repeat, terminate or not. So this one terminates, has the dots at the end, but this one doesn't. So this is a terminating decimal. Okay, so at the bottom, please also note some subtle changes. These two questions are about decimals. Tell me one that is rational and one that is not rational. So they should have a decimal point there, right? A rational number in decimal form is one that is going to terminate or repeat. So for example, this decimal terminates. That would be a good example that you can't take, sorry. Or repeats. Again, a good example that you cannot take, sorry. And then an example of a decimal that is not rational, irrational. So this would be a decimal that does not terminate, does not repeat. So honestly, these are just a jumble of numbers that I wrote down to show repetition with the dots at the end. I should have only done 3, not 4. Okay? Please don't steal my example. And then at the bottom, in your own words, tell me what's the difference between rational and irrational numbers in fraction form. And you could probably steal really close to the answer to that off of the notes that we took today. There is a line on our notes that talks about the difference between rational and irrational numbers in fraction form. Okay? All right, that was a very rough run-through of what we did in class. A little bumpy, sorry about that. If you still have lingering questions, I'm going to try to write a lot without making it too sloppy. drones at d231.rochelle.org net. And I'm very happy to help you if you have any additional questions. Again, I'm always happy to help. You're not a trouble to me, or you can come see me